In this video, I'm going to teach you how to determine the number of signals on a compound. Now, this image of an NMR spectrum comes from the UCLA chemistry website. Here, there are 5 signals on the spectrum. 1, 2, 3, 4, and 5. Now, there are individual peaks within those signals, but that is due to splitting, which I'll talk about in my next video. Now, these 5 signals correspond to the 5 different environments that the hydrogens in this compound are in. That's one environment there, the OH. That's 2, 3, 4, and 5 different environments. And these numbers don't necessarily correspond to the numbers I've put on the spectrum. That will have to do with chemical shift, which will also come in a later video. But when you're looking at a compound, every hydrogen that's in a unique chemical environment will have its own signal. And what a unique chemical environment means is that basically there's no symmetry. You have to look for symmetry in the compound. And if you don't see symmetry, then every single signal you have will be unique. If there is symmetry, you may have 2 different hydrogens that are on different carbons but have the same signal because there's symmetry. It can be a little confusing, so the best way to explain it is through a few examples. So in example 1, I've got an ether here. This ether has 3 signals. 1, 2, 3. There's no symmetry in this molecule. So each hydrogen environment is unique. Right, the 3 hydrogens here, they're all identical. Right, so we're considering them the same hydrogen basically. That will come with integration, which will be another video where we'll determine the number of hydrogens. But here, this is all the same signal because they're on the same carbon. Then the 2 hydrogens here are on the same carbon, so that's another signal. And then finally, we have the signal down here with those 3 hydrogens. Now, example 2. So this is our compound here. There are 4 signals in this compound. There's a little bit of symmetry here now. That is one signal. That's a second signal. Signal 3 right there. But then here and here, those 2 methyl groups are identical to each other because both of those methyl groups are bonded to the same carbon. You can't differentiate between these 2. Remember that single bonds are always rotating, so those bonds are going to be rotating and you can't differentiate between those 2 methyl groups. Right? So there is only one signal coming from these 2 methyl groups combined. Example 3, I'm going to put in here, is similar to the initial NMR spectrum that I showed, an alcohol. This would have 3 signals. The hydrogen there is 1, 2, and 3. I wanted to bring this up because hydrogens on either a nitrogen or an oxygen, they don't always appear in the NMR spectrum. So that's just something to note. They aren't always going to appear. Then lastly, this is going to be a great example of symmetry that hopefully will help you a little bit more with determining signals. I'm just going to draw benzene. I'll put the hydrogens in here too. So each carbon has one hydrogen on it. So there are 6 carbons and 6 hydrogens, but only one signal. All of these are in the same chemical environment, and that is because of symmetry. Right, if I draw a dotted line here, I draw one there, draw one there, this molecule is completely symmetrical. So every single one of those hydrogen chemical environments is identical. So just because something has a certain number of carbons or a certain number of hydrogens, that's never going to be able to tell you on its own how many signals. You need to look at the compound, look for symmetry, and determine from there. I want to do one more to show some symmetry. So here, we have one signal there, a second signal there, a third signal, a fourth signal, right? Because even though the blue and the green are both bonded to the same carbon, the green is then bonded to an oxygen, while the blue isn't bonded to anything else. So that's how we know that even though they're bonded to the same carbon, that doesn't mean they have the same signal or the same chemical environment. There's no signal on this carbon because there's no hydrogens bonded to it. And then I'm going to get a new color. These are all the same signal because they're bonded to the same carbon and none of them are bonded to anything else. Right? If I drew in, say I drew in one thing, so now we had an ethyl group here and then just 2 methyl groups, this would be its own signal and that would be its own signal. But because all of them are methyl groups, they are all the same chemical signal. I know these signals can get confusing, and it's great to, the best way to really work on them is just to practice over and over again. But hopefully this video was a good help to kind of introduce chemical signals and how to determine the number of them and whether signals are unique or not based on what they're bonded to and based on the symmetry of the molecule. So in the next video, I'll go over splitting and integration.